Hello everyone, I am Masood Ibn Abdul Wahid. Today in this video we are going to discuss about the superposition theorem, its statement, problem we are going to solve. So it states that in any linear multi-source complex circuit, the voltage or current in a particular resistance will be equal to the algebraic sum of voltage or current in that resistor with the consideration of one source at a time, and all the other sources are turned off or made inoperative. The meaning of the statement is, so if we have an electrical network with multiple sources, it may be multiple voltage source, or it may be multiple current source, or it may be combination of both the sources. To find the particular current or voltage, except one source, all the other sources will be made inoperative. The meaning of the word inoperative, if it is a voltage source, we will be short circuiting it, leaving back the internal resistance of it. And if it is a current source, we will be open circuiting it, leaving back its internal resistance. So for example, we will take this circuit. So this circuit has multiple voltage sources, and let us assume that we are in need of finding the current through the 1 ohm resistance, which is marked as load current IL. So since it is having multiple sources, by applying superposition theorem, we will be considering one voltage source at a time, and we will be short circuiting the other sources since it is a voltage source. If the other source is a current source, we will be open circuiting it. So with the 4-volt battery acting alone, we will be calculating the same current through the same resistance. Since only one battery is acting, we will notate it with a new term called as IL1. With the second source acting alone, we will be calculating the same current through the same resistance. Since the second battery is acting alone, we will notate the current through the load resistance as IL2. So we solve the same network twice by considering one source at a time. So the total current through the required load resistance, which is IL, is equal to the algebraic sum of the answers found by considering one source at a time. So this is what the superposition theorem states. So let us take the same circuit and we will solve it. So this is the question given to us. Find IL using superposition theorem. And to apply the superposition theorem, we need to consider one source at a time. So out of these two batteries, we will consider the circuit with 4-volt battery alone. So whereas the other one will be short circuited like this. So 4-volt battery is considered alone, with 2-volt battery being short circuited. So by doing so, we will have a parallel connection between the 1 ohm resistance and 4 ohm resistance. So to find the current through 1 ohm resistance, which is IL1, we need to find the incoming current of this node. By knowing that, we can apply the current division rule and we can get the current through 1 ohm resistor. To find the incoming current to this node, we will solve this two resistance in parallel combination. As it is connected in parallel, 1 by R equivalent 1 is equal to 1 by 1 plus 1 by 4 can be calculated as 0.8 ohm. So now the current through the 2 ohm resistance, or also the current delivered by the battery, can be written as I2 ohm is equal to the battery voltage V divided by the equivalent resistance between the two series connected resistors. One is 2 and another is this 0.8 ohm, for which I2 ohm can be calculated as 1.429 amps. So this is the incoming current for this node. So when you know the incoming current of this node, we can apply the current division technique at this node. By applying so, the current through this 1 ohm is equal to incoming current, which is 1.429, multiply the opposite branch resistance for this 1 ohm, it is 4, divided by the total loop resistance, which is 5, as written here. So this is written with reference to current division technique applied on this node. IL1 equal to 1.429 multiply 4 by 5, which is equal to 1.143 amps. So this is the current which we have calculated by considering only the 4-volt battery alone acting. So now we will take the network with 2-volt battery acting alone. So for which the circuit is this one, 2-volt battery is considered, whereas the 4-volt battery is being short circuited. So by short circuiting this, we will have a parallel connection between the 2 ohm resistance and the 1 ohm resistance, for which the R equivalent can be calculated as 1 by R equivalent 2 is equal to 1 by 1 plus 1 by 2. So which in turn R equivalent 2 can be calculated as 2 multiply 1 divided by 2 plus 1, which is equal to 0.667 ohm. Now after solving this for parallel combination, so this 0.667 and the 4 ohm resistance will be connected in series. The current delivered by the 2 ohm battery or the current through the 4 ohm resistance can be calculated as the voltage 2 divided by 4 plus the parallel combination of this 2, which we have calculated as 0.667. So the current through 4 ohm resistance will be equal to 0.429 amps. So this is the current which is coming into the node. So by knowing that incoming current, we can apply current division technique. The current through 1 ohm resistor, which is IL2, equal to incoming current, which is 0.429, multiply the opposite resistance of this 1 ohm, which is the 2 ohm, divide by total loop resistance. So it is equal to 0.429 multiply 2 divided by 3. In turn, it is equal to 0.286 amps. So up till what we have did is we have calculated the current by considering one source at a time. So with the 4-volt battery acting alone, IL1 is equal to 1.143 amps, and with the 2-volt battery acting alone, the current IL2 is calculated as 0.286. Now by applying superposition theorem principle, the total current through the 1 ohm resistance will be equal to the algebraic sum of the two currents which we found by considering each source at a time, which is IL is equal to IL1 plus IL2. By substituting the values, IL1 can be found to be 1.429 amps. We have manually calculated. Now as usual, we will plot this in the Proteus simulation and check what is the current read in the 1 ohm resistance place. As I said, I have plotted the example schematic in the Proteus software. So here one inclusion what we did is we have inserted the ammeter to read out the current through this 1 ohm resistor. Run the simulation. You can find the current through that 1 ohm resistor to be 1.43 amps. So we have manually calculated the current through 1 ohm resistance to be 1.429 amps, and in the Proteus simulation also we read it to be 1.43 amps. So in today's video, we have discussed about the superposition theorem, its statement, and we have took one example problem. We have solved the network by applying superposition theorem, and we have found the answer manually, and the same answer we got it in the Proteus simulation. So hope this video was useful to you. Thanks for watching. We will meet in the next video by taking some university question problems related to superposition theorem. Until then, I am Masood ibn Abdul Wahid signing off.